We've covered them one more time. These may be on the test, and you need to understand the terms. We're going to start at the very basics when we first start. The very first thing we need to cover is voltage. Voltage is electrical pressure or push. Okay? That's how much pressure we have on a circuit. Obviously 12 volts pressure is going to be more than 6. And so we measure electrical pressure or push with a voltmeter. And you've got to remember, the only thing the meter tells you is the difference in electrical pressure between the negative or the black lead and the positive or the red lead. That's all it tells us. Come on and sit down. All right, that's critical when we get into voltage drop. So if we're checking a battery and we go to the negative post and it's got 0 volts, and we go to the positive post and it's got 12, it's going to tell us the difference. 12 volts. Okay, that's all the meter does. Now, the second function of electrical is amperage. Amperage is the amount or flow. It would be like gallons per minute in a water system. Okay, we have to have the correct amount of flow to make something work. So if we have a motor, for example, that requires 10 amps for it to run correctly, and the system only has 5 amps because we have lost the push and we can't push the flow through there, the fan's going to run slow. You see this all the time in a headlight, for example. You're driving at night and somebody's coming towards you and you'll notice that one light is bright, the other light is dim. You ever seen that on a headlight? Okay. The reason the light is dim is because it doesn't have enough amperage or flow to make the bulb light. And the reason it doesn't is because usually we have a resistance in the circuit, so it takes part of the pressure, the voltage pressure, to get through that resistance, so it can't push the amperage. Okay? We lost pressure somewhere. And we've got to find it. That's what makes the lamp dim. We lost pressure, it can't push the flow through, so the light is dim. Okay, I'm going to cover that a little bit more later on. The third thing I just hit on is ohms. Ohms is resistance to flow. Okay, now I want you to think about it in this way. If we have a sprinkler system, comparing it to water, and I run it from the tap, and it runs through a filter because I'm using irrigation water, and I have a pump, and it comes and I have 2 sprinklers, and each sprinkler requires 10 gallons per minute. I turn on the pump, and as long as I'm pumping 20 gallons a minute, both sprinklers spray correctly. Okay, I'm going to build pressure with the pump. I'm going to use the electrical numbers. I have 12 pounds pressure with the pump and 20 gallons flow. My sprinkler system works fine. I go out and turn it on one morning, and instead of having them spray out 20 feet, they're just barely spraying a little bit like that. Okay? Our flow is gone, right? We can look at it and tell that the flow is low. What could cause the flow to be low? If we lost pressure, resistance. Okay, we lost pressure from resistance. So if a bunch of leaves come and catch in that filter and the pump's trying to pump, and it uses so much pressure trying to get through those leaves, it can't push any more water. Okay, and it's a loss of pressure which affects flow. Electricity is the same way. If we have resistance in a circuit, it takes pressure to get through that resistance, and since we use the pressure to get through the resistance, we can't push the flow, so the light is going to be dim. All right? That makes sense? They tie together. All right. So we've got pressure, flow, and we have resistance, and they're all 3 part of the electrical circuit. The next thing I went over is a series circuit. A series circuit means that everything is in a line. So if we have positive voltage here, we come out and we have a switch here. We're going to have a load. We may have another load come through and we have the ground. Everything is in a line. Okay, that's series. When we close this switch, all the lights come on. The problem with a series circuit, which is what we use most of the time in the car, is if I have an open anywhere in this circuit, it shuts it off. If this bulb burns out, I have no flow anywhere. If this ground breaks, I have no flow anywhere if the switch is open. All right? So it's in a line, a straight line, and anywhere we have an open in that, it shuts the whole circuit off because we interrupted the flow. We can't have any current flow, so it can't get through. All right? A parallel circuit means that we have one power source, and it comes and it may feed this one, and this one, and this one. An example for this would be lights on the cab of a truck. We have one 12-volt circuit. Okay? These are side by side. They're all fed by the same voltage. And in this circuit, since they're side by side, if this one burns or breaks off or has an open, both of these others will continue to work, correct? Yes. Okay. That's what we want on the cab of our truck. I don't have time to go through voltage drops and everything in the circuit. This is just a reminder. We use a parallel circuit so we can have the lights on the cab of our truck work, and if we lose one, the others stay on. Now, we're going to use a combination of series and parallel in this circuit, and we do that for a reason. Everything from here to here is in a line, right? To get to all 3 volts. That means it's in a series from here to here. So if I put a switch right here, I can turn on or off all 3 lights with one switch, because it is a series in a line, parallel, side by side. Okay? I can put a fuse. If I want to put a fuse in the circuit, I can put it here. Some of you have been looking at light circuits, and they use a parallel circuit. And on this one, they're going to put a fuse. And this one, they're going to put a fuse. This one, they're going to put a fuse. Why did they do that?
In case that side or that part of the parallel circuit has a problem.
Okay, if any one of these circuits has a short to ground or burns up or has a problem, this fuse will burn, the others will stay lit, and I can go find the problem. The new headlight circuits have a fuse for each headlight, but they're also going to have a master fuse up here in the circuit. So if we have a high current draw, it pops this fuse and they all turn on. I'm covering this because we've got to know that for diagnostic purposes. If we lose all the lights, we're looking at something that affects all the lights, which would be in a series part of the circuit. If it only affects one light, okay, then it's only that part of the circuit. So if this one fails, I don't need to check all of this. It's got to be good or the others wouldn't work. Okay?
So, even though the switch is in there, would we still call it a parallel circuit, or is it
The lights are parallel circuit. This is series, so this would be called a series parallel.
Okay.
We do that for protection, for switches, those kind of things. Series parallel circuit. Now, I want to point out one thing that is confusing in the books sometimes. A series circuit, this one, is made up of 3 series circuits. So if I take these 2 out, isn't that a series circuit right there, all in a line? So if I'm doing diagnosis and this one doesn't work, isn't that a series circuit all in one line?
Yeah.
And so is that one.
Yep.
So I take 3 series circuits, give them one power source. That means that they're operating side by side or parallel through a series part of the circuit. But each one of these is an independent series circuit. So when we're doing diagnostics, we can break it down and see, is it something that affects all of them? It's back here. If it's only one of them, it's that branch. And if we get to that branch, now we can break it down, and our diagnosis for a series circuit is only for that line. And it doesn't make any difference if it's a computer with 65 wires in it, or your fog lights, or your cab lights on your truck. They all work the same way. And so a computer with 65 different circuits may be fed by one fuse to the computer, which is series. The computer may break it out in 40, 50, 60 different wires, but each one of those wires is a series circuit fed by one source, which makes it series parallel. One feed side by side. If you make it too complex, you will not figure this stuff out. If you keep that in mind, and you find which part of the circuit that I'm checking, which one of those 65 wires has a problem. That's kind of where we're at on yours, Corey, that I was telling you yesterday. We need to find out on his vehicle that he's working on, because we're just starting on live problems now. If you have something that's, say, 5 different things that are affected, part of the diagnosis is let's look what can affect those 5 things. If we have one power feed that feeds your brakes, your tail lights, your signal lights, your your hazard lights, your dome light, and it's all fed by one source, and all these are affected, guess what? You're probably back here to this one, right? If it only affects 2 of them, then we need to go somewhere else. And a lot of times you're going to find that these 2 end up with the same ground, and maybe with your blower motor too, because of where they're located on one lug. And so we also check the ground side, because the power feed side of the series may be different from the ground feed. We always check power and ground. Okay, we've gone through volts, amps, ohms, a little bit on series, a little about parallel. This is just a review, basically how they work. I have time to go a lot deeper than that. Okay, that's good.